this video, we're very quickly deriving formulas for derivatives of natural logs and non-standard logarithms, and then we're applying to some simple examples. So let's get started. First, we're asked to derive a formula for the derivative of the natural log function by inverting this equation y equals natural log x. In other words, I want to re-express it as e to the y equals x. And then this idea of implicit differentiation, it's really just another way of looking at the chain rule. When I differentiate with respect to x on both sides, well, e to the y is a function of a function because y is a function of x. So when I differentiate with respect to x, first I differentiate e to the y with respect to y, then I multiply by the derivative of y with respect to x. That's the chain rule. On the right-hand side, I get 1 because the derivative of x is 1. And then the whole point is to solve for dy dx. And I get 1 over e to the y. And then I replace y with its definition in terms of x, which is right here. And I get 1 over e to the natural log x. And then I have to remember that the natural log function and the natural exponential function are inverses of each other. So e to the natural log x is just x. All right, so that's done. There's a little bit more to the story here because the thing I differentiate to get 1 over x is a little more general than just natural log x. It's not that our answer is incorrect here. It's just that I don't want to miss the opportunity to generalize. So I want to point this out. If I look at the derivative of the natural log of negative x, well, negative x is a non-trivial function. So I have to use the chain rule, and I differentiate with respect to negative x. That gives me 1 over negative x. And then I have to multiply by the derivative of negative x, which is negative 1. And those minus signs cancel, and I get exactly the same number. So I could generalize by saying that really the derivative of the natural log of the absolute value of x. Now the absolute value, it either leaves x alone, so it's equal to x, or it multiplies it by negative 1, so it's negative x. Well, either way you go, if you differentiate, you get 1 over x. So that's sort of the most general thing I could differentiate to get 1 over x. And when you're going backwards and trying to, and sort of looking at 1 over x and trying to think what you could differentiate to get that, it's important to keep that generality. All right, but let's go ahead and apply the derivative formula to this first example. It says compute f prime of x for f of x equals natural log of x squared minus 3x plus 5. So this is a function of a function. I'm going to differentiate with respect to this argument, treating it like a single variable. So the derivative of the natural log of this thing is just 1 over this thing. Then the chain rule says you have to tack on the derivative of that interior function with respect to x, and that's going to give you a 2x minus 3. Cleaning things up a little bit. I get 2x minus 3 over x squared minus 3x plus 5, and that problem is done. The second derivation in this video is to generalize to a log with a different base. And the way we're going to do this is to just quickly apply the change of base formula. If you've forgotten it, the change of base formula says this. If I have a log base b of some number a, I could re-express this in terms of a new base c by saying log base c of a over log base c of b. And in particular, we don't really want to use some general c here. We want to use a base of e, in other words, a natural log. We want to compare to a natural log because we already have a derivative formula for that. All right, so our function y is log base b of x, but that's the natural log of x over the natural log of b. And the natural log of b is just a constant. I'll just write 1 over natural log b out in front times natural log x. Well, now what do I get when I differentiate y? I end up with a 1 over natural log b out in front times the derivative of the natural log of x, which is just 1 over x. And we've got a formula for the derivative of a log with a non-standard base. In our example, we're just asked to apply the formula directly to a log base 2 of x. And we've already got the formula for it. So it's just 1 over natural log 2 times 1 over x, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.